Good morning, afternoon, evening, wherever you are, and welcome to the latest edition of Free Thought Hour. Now, I've got to report, sadly, Tercia can't be with us tonight. Never mind, I've still got our guest. This is Alistair. Hello, Alistair. How the devil are you?
I'm doing well, John. How are you doing?
Yeah, I'm fine here too. I've just had a busy day. I went up to national. Let me get this right. A national secular society. I can't.
There we are. Too many S's.
Yeah, can't speak suddenly. It's a meeting in Birmingham, so I had a bit of a rush journey. For us, it's a long way. You know, it's 150 miles there and 150 miles back. So,
Oh, that's a long way. In
by,
the
by,
UK.
By our standards, yes, it is.
Yes. In the US, that's a day trip. Yes, where I am based.
Yes.
Yeah. So I'm in Portland, Oregon, where right now it's a bit horrible because it's wildfire season. The sky is this horrible brownish orange. Went for a walk earlier, it's like smoking a cigarette. So hopefully it'll clear up in a few days. But I'm housebound today.
With your windows shut?
Yeah, windows shut. Yep, so it's getting a bit hot in here. But
there was some interesting research published recently about air pollution and how it triggers cancer, which is sort of lurking, even in non-smokers.
Oh, really?
Don't know whether you saw that.
Nope, never heard of that. That's interesting.
Yeah. So, tell me, this is a question that we expose all our victims to.
Excellent.
How did you get to be the person you are today?
Oh, cool. Well, interesting. Yeah. Well, so for, I guess, a bit of background, I'm originally from Warrington, which is between Manchester and Liverpool in the UK. Yep. I immigrated to the US with my parents when I was quite young, about 20 years ago. Moved to the middle of nowhere in eastern Washington, which is it's the desert. That's where they manufactured the plutonium during the war for the nukes. As a side effect of that, you have a high concentration of scientists and engineers in one area. Yep. And they've plopped a national lab down there. So my dad is an engineer, so I've always kind of been interested in science and engineering. Yep. So in school I studied physics, and I currently am working on my PhD in applied physics while working for a US national lab, who I am not in any way representing right now. All of my opinions are mine, not my employer. I always got to say that.
Yes.
My research, disclaimer, there. So my research primarily deals with energy storage materials, mostly lithium-ion batteries. So trying to characterize their performance and degradation. So I've got a background there in science. I'm a scientist. And it's also that I think kind of the main reason I kind of got interested in like free thought and so on was kind of that move from the UK to the US.
Yes.
I was raised in a Church of England school where in the Church of England, family didn't really take religion too seriously. Religion was really kind of a background thing, be nice to each other sort of thing. Never really thought about it too much. And then moving to America and talking to other kids in school who didn't believe in evolution. Oh, we've lost John, have we?
No, I'm still here.
Okay, excellent.
Just put you full screen so you can tell your story.
It's kind of made me think a lot more about pseudoscience, and got pretty interested in specifically the pseudoscience of creationism and its more upgraded modern version, intelligent design. So I'm wanting to talk about that somewhat, but that's where I kind of started thinking about maybe the bad sides of religion, which I don't think I was too exposed to in the UK, and that you get a lot more exposed to in the US, where it's a much bigger part of life, where you're much more familiar with its toxicity, and just people you know day to day might have these ridiculously toxic or regressive ideas, or these incredibly anti-scientific ideas, which was kind of a bit of culture shock to, kind of a young, science-minded, dorky kid who hasn't been exposed to people who don't believe science is real. So that's kind of my background there, my life story, and now you know literally everything about me.
Fine. Okay. Well, it is a bit of a culture shock, isn't it? Because I interview a lot of Americans, many of them who have tunneled their way out, because pretty much everybody in America is raised devoutly in a faith.
Yes.
And they have to, if they do come to their realizations, they have to excavate themselves from this.
Yeah, it's a whole process, and it can take a long time.
It can be very distressing. There's organizations to rescue people who are suffering from a version of PTSD that they've been left with. Yeah,
that's definitely the case. Yes. Pretty much everybody I know has some sort of religious background. Quite a few have some sort of religious trauma, even. But I'm in a more ostensibly progressive, liberal part of the country now, in Portland, Oregon. It's been razed to the ground by Antifa super soldiers. So no Christianity anymore here. God has abandoned this land. So that's quite nice for me. I know most people my age who I know socially definitely do not take religion very seriously or are part of a religion at all. It's quite uncommon.
It very much depends where you are in the States, doesn't it?
Oh, yes.
The coasts are broadly irreligious.
Yes.
But the rest of it is very much, verging on fundamentalism.
Yes. Even in Portland, you drive only maybe 20 miles outside the city and you're basically in Alabama.
Yeah.
I think most America is like that, even, no matter, it's a few dots of quite progressive cities, and then gets a lot more religious fundamentalists outside of that. There's a drive from Portland up to Seattle in the north, and you go through the mountains for that in the middle of nowhere, and it's just full of signs about how you're going to go to hell if you don't accept Jesus into your heart, which is a bit weird.
Not kidding. Yeah. Well, we were saying before we went live that the situation is the reverse over here, because in the States you technically have a secular constitution.
Yes.
You're not allowed technically to merge a church with the government.
Yes.
Here we have an established church.
Yes.
Whose leader has just died. The Queen has just, very sadly, lovely lady who will be a very hard act to follow. She did the job of Queen superbly well.
Yes.
But she's was technically the leader, the head of the Anglican Church, which began, 530 odd years ago by Henry VIII. And when he wanted to divorce his first wife, that happened to be his brother's widow, and it all gets very complicated. But so since then, we've had an established church, a state religion, yet it's become sort of moribund. There was no need for it to fight to get recognition because it was part of the state. So it turned out, as you were saying, you were raised in it, it's turned out to be a sort of sleepy old religion, which nobody has to believe anything particularly. You just go along on Sunday for the tea and cakes.
Yes.
It's a social event. Not even the clergy have to be believers.
That's true. Yeah. I remember my, I don't know what you call him. Would you call it? It wouldn't be a priest, would it? Vicar, I guess, in my Church of England school was definitely very chill about it. He didn't press the whole Jesus thing that heavily, as opposed to just kind of being nice to each other.
So I wonder if America had done the same thing, if it had established Christianity as the state religion 200 or 300 years ago, would all of this baptism, fighting for actual representation, getting candidates to apply for posts, would that have died out the same way that our Anglicanism has?
That's one thing I wonder. Yeah, I have zero sociological background, and I'm working off of vibes here completely.
Mm,
But I do wonder if there's been some form of social Darwinism where, in America, with
mm,
religion being a lot less regulated, the religions that are best at reproducing and
mm,
converting are the ones that survive and pass on,
mm,
and those are the fundamentalist and evangelical
mm.
churches in the
Yeah.
US. Uh, Even though obviously religious freedom is very good, especially for religious minorities such as ourselves. But it is kind of interesting how
Not
that is.
non-religious minorities,
Yes,
please.
yes, 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 yeah, of course.
Yeah.
But yeah, it is kind of weird how that turned out. I'm sure
So
I'm very wrong about something because I don't know this subject, but
it's not
yeah,
my strength either. No.
it's
So
that's the flaw of every physicist, right? Is that they always think they can explain every single little thing because everything's just atoms colliding, right? So
yes, we've seen how that works out with some people too. I'm thinking of Linus Pauling, for example, although he was a chemist, wasn't he? Who the trouble is, once you get to be triple nominated for the Nobel Prize or something, it goes to your head, and you think you know
yes,
everything about everything. And so he advocated mega doses of vitamin C, and turned out to
yes.
be complete nonsense.
People still believe in it though.
Mm,
My mum still tells me to load up on vitamin C whenever I have a cold. So
yes, yes.
sorry,
Well,
mum.
yeah. So let's talk about your research for a little bit. I know you can't give
Sure,
away any state secrets or company secrets, but
that's true.
batteries are going to play a large part in the future of this planet, aren't they?
Yes, yes, and they already are actually. I mean, so what everybody knows about already is, obviously batteries have a big role to play with renewables right
Mm,
now. You know,
mm,
right now, every single well, this was more true even a few years ago, but every single electron that comes through your plug was generated right this second in a power plant somewhere, right? Uh,
yes.
but that's not how renewables work. I mean, solar only works when the sun's out. Little obscure fact there, and wind turbines only work when the wind is blowing. So
No.
yeah, that's another obscure fact there. But yeah, so batteries are essential to make renewables viable to
Mm,
move the energy in time from when you
yeah.
need it to when
Well,
it's produced.
either
But
either batteries or pumped storage systems.
yes, yeah,
We have a
uh,
couple of those here, but
yeah,
obviously not enough capacity.
yes. Pump storage is great because in some ways, the main one being that obviously you've already got a big dam for generating hydroelectricity, so you may as well uh, use it to
Run it
store energy
backwards.
as well. Most energy storage on the grid is in that form right now.
Mm,
It has one major drawback is that, uh, over, especially in the last few years again, because this is a rapidly changing field,
yeah.
um, it's not a very cost efficient way to store electricity if that's all you're doing. Water and gravity is not very energy dense compared to
Yeah.
what you do with electrochemistry. Uh,
Yes.
but it is playing a role, it will continue to play a role. Uh,
Yes.
but yeah, batteries are evolving rapidly. The cost has come down
Mm,
by massive amounts, even in the last few years.
mm,
And one segue I was actually doing by talking about renewables is that around the US, utility companies are installing batteries on the grid, not
yeah. Yeah.
just for renewables, but because even if you don't have a single renewable on the grid, it's actually very useful and saves you a lot of money to deal with power outages,
Yeah.
to deal
Smooth
with
out the bumps.
yeah,
Yes.
yeah.
Mm,
Typically, utilities spend a lot more money, not just how much energy they provide, but yeah, the peak each day and each
yeah.
month.
Yeah.
The higher that is, the more expensive it is, and
Yeah.
flattening that out
Mm,
is quite valuable. A lot of rural communities around the US have frequent power outages,
mm,
and having a battery system on the grid to give a few hours of power in that case
yeah.
is very useful
Mm,
economically. So utilities are, especially with the cost decreasing so rapidly, we have hit this tipping point a few years ago where utilities are kind of jumping to buy these battery systems and put them on the grid.
yeah. Well, I've got a couple of questions I want to explore
Oh, sure,
from that. One is why lithium? Because we've been through a number of
sure.
different battery types, haven't we?
Mhm.
There was lead acid. There was one before that, wasn't there? Sodium hydroxide and what was that? The Leclanche cell. I don't know if you're
not familiar with that. No.
Yeah.
Yeah.
No,
I mean,
okay. And since then, of course, we've had NiCad, haven't we? And now through a number of there were some others in between, but through a number of iterations, we've ended up with lithium. And this is now here's my way of thinking why. This is because it is both a very small atom
yes.
and a metal.
Yes, that's exactly what I was going to say. Is that it's very tiny. Its atomic number is only 3, and it's very easy to ionize. And sorry, this is Lily, my cat, by the way.
Hello, Lily.
Yes. So it's very easy to run the reaction both ways, charge and discharge, which isn't so much the case with stuff like nickel cadmium, for instance, which is why you would only buy those as primary batteries. That you buy them from the shops, you use them once, and then you throw them away.
Yes.
While with lithium-ion batteries, because the properties of lithium, it being very small and very easy to ionize, the reason that it's useful that it's small is that the reaction that's happening in the battery is that you have a carbon matrix in the electrodes, and lithium needs to go in and out of that, and it has to push in.
Expands and contracts.
So it expands and contracts. So if you have a bigger ion, that's going to crack and break, and take your battery back.
It's amorphous carbon, isn't it? It's full of holes like a sponge.
It's exactly like a sponge. Yes.
So hydrogen would be even more perfect, but the damn stuff is a gas.
Yes, that gives some perks and some drawbacks. I'm a bit bullish on hydrogen in general in terms of energy storage. Producing hydrogen is still useful. One big thing that's useful about hydrogen is that because it's a gas, you can compress it quite small. So if you're in a place where land value is very high, a hydrogen storage system can be very attractive. One very major drawback to its efficiency, though, is that when you compress a gas, it gets really, really bloody hot. Then you have to take that heat out. So you have to store the heat as well as the hydrogen, because when you put the heat back in, it expands. It's very chilly. You need to warm it back up.
Yes. The principle of refrigeration.
Do
you want to let your cat out? I think she wants to.
Oh no, she likes being in here.
Okay, right.
So that's actually a door she's not allowed to go through because it goes to the garage.
Oh,
okay. But it's more rambling about hydrogen, actually. What was it though? So typically you want to store hydrogen at like 300 atmospheres of pressure, which going from 1 atmosphere means that you're going from room temperature about 300 Kelvin to 90,000 Kelvin, which isn't doable. And if you let it warm up room temperature, what's compressed, that means it's going to cool down to literally 3 Kelvin, which isn't really possible. So that's one drawback. But one thing that's very useful about hydrogen in terms of decarbonization is that there's some applications which you can't really electrify, high heat industrial processes such as steel and concrete manufacturing. And in that case, making green hydrogen with electricity that you can burn in those processes, that's useful industrially. So that's where I think hydrogen would be very useful in the green economy, not so much for cars where you need very expensive platinum electrodes to make them work.
What about the green, in quotes, aspects of batteries, particularly lithium-ion batteries, from the point of view of their manufacture and disposal?
Oh, sure. Yes. I mean, that is an ongoing issue, right? I mean, when you manufacture a lithium-ion battery, it has a set life. That's what most of my research deals with, how they degrade over time. So being able to quantify how long lithium-ion battery lasts.
And how many recycles.
Until it's time to recycle. I've really kind of dabbled in the recycling aspect, so I don't know too much about that. Apart from, I know when it's time. What's that?
I meant how many recharges. Sorry.
How many recharges? Yes. Yeah.
So that's your particular area of research. Interesting.
Yes, specifically how to quantify it, because there are so many different chemical reactions going on that are very hard to tease out. And you often find in the literature that they do kind of overfit onto individual chemistries. So it's kind of hard to take results from one system and apply it to the other, if that makes sense, because I might be attributing everything to one specific chemical reaction.
When there's several going on in parallel.
Yes. So kind of what my thesis is dealing with is how to make a more general model that you can apply to multiple different chemistries without overfitting onto one, or kind of modeling all those chemical pathways. And
Well, you ought to speak to Professor Lee Cronin at Glasgow University. Actually, he's in the States right now doing a presentation somewhere. But his thing is computation.
Computation. Not familiar with this.
Well, he's I suggest you Google it and find out a bit about it, because he's trying to turn. He recognizes that the chemical space is much better, much larger than the cosmological space, because of course you can make anything. There's infinite number of compounds that can be produced from our 100 and a few more elements.
It's very unintuitive.
Yes. So he's trying to devise a system whereby you would be able to manufacture using equipment pretty much any compound.
Yes.
He's calling it computation. I'm not. It goes over my head. But I had a very interesting conversation with him about, I don't know, 2 years ago on this show, and I recommend that you check out what he's doing, because it not only deals with that computation idea, but he's also investigating the possible origins of life.
Yeah, I was actually going to bring it back there, because kind of swerving wildly to intelligent design, I think whenever I'm talking to those advocates, typically intelligent design is an argument from ignorance, and typically they do wax poetic about how we've not figured out which chemical reactions have brought about life, which is true. But I think one thing that really breaks intuition is that we don't have a science computer where we say, we have these chemical ingredients, what happens? As soon as you add more than one or two chemical reactions, it gets really, really complicated really quickly. Even the simplest reactions that you get taught in school, there's several in-between steps that you don't know about, and all those interact with each other, don't they? And even basic properties of water, we don't know that much about.
No, it's such an interesting molecule, isn't it?
Yeah.
So we were taught, I taught to the younger school children the simple basic equations of this atom and that atom come together or split up, and that's the product. But of course, as you say, there's all sorts of
version.
Yes, indeed. There's all sorts of actual goings on with charges moving around, and partial charges even that influence the way electrons move, and in transitional semi-compounds that have a brief half-life in between what's going on in the main equation. So do you want to do that now? Do you want to take a look at ID? Because you're right in that it's an argument from ignorance, but they like to say, no, it isn't, because what we're doing is we're applying reasoning like you do in science.
Yes.
And we're saying, look, this is such a statistically impossible thing to happen naturally. Therefore, it must be by some intelligent agent.
Yes, is the Steelman version.
That's their argument from ignorance.
Yes. In practice, whenever you push them on this, it does end up as an argument from ignorance. But I think it's nice to take an argument in its best possible configuration and address it. What they are touching on is it's a useful question to analyze: is this thing designed or not? There are many fields of science where that is a useful question to understand. There's archaeology, where archaeologists want to guess if you find a rock, what is it, just a naturally formed rock, or is it an arrowhead someone made thousands of years ago? There's a search for extraterrestrial intelligence, which I think is much more of a analogy here, because intelligent design advocates don't think that humans design life. Obviously, they think that something above humans did, a deity. So that's much closer to the search for extraterrestrial life, SETI, where you have to kind of discern what a non-human intelligently designed thing would look like. And that's not a trivial problem to solve. And to my knowledge, I'm guessing wildly here, I don't think they use anything from the intelligent design movement to kind of try and figure out if a signal is alien in origin or natural in origin.
Well, not to my knowledge either. No.
Yes. In fact, a lot of the
Can
ID. Oh, sorry, rambling here.
Rocks a bit, because it can be quite difficult to tell between sort of early Roman concrete and a piece of conglomerate.
Oh, really?
Because they superficially they can look very similar.
Are there specific things they look for to tell the difference there?
I don't know. I did geology way back.
Oh, yeah.
Part of my first degree, but I'm not an expert, so I wouldn't be able to answer that question. But I do know that it isn't immediately obvious if you pick up a lump of stuff, whether it was actual Roman concrete, because they use different materials for concrete than we do today. They didn't have Portland cement. Oh, Portland. Different Portland though. This is our one.
Yes.
And conglomerate is a rock which has formed by a mixture of different sized sedimentary particles that can superficially resemble concrete.
That's something that people who are taking intelligent design seriously should take a serious look at then, because that's like a very obvious place to test. How can we tell if this is intelligently designed or not?
I have views on this. I'm going to announce them before we show your slides, because coming from a retired science teacher's point of view, I would say that signs of something having been designed. Oh, and here's the first thing. They want to try and separate design from creation, from making. This is why the intelligent design movement sprang up, because the American Senate, the federal government, banned the teaching of creation as a science lesson.
Yes.
And so they slid sideways and said, we're not doing that. We're teaching intelligent design. And for that to be the case, they must separate design from creation. But you can't, because if you ask somebody to make something, the first thing they do is design it.
Yes, that's true.
The beginning of the process. So that's the first problem, the hurdle that they've got to overcome. But I always say to them, well, if I want to know whether something is designed or not, I look for whether it's made from natural materials, whether you can see signs of tooling, where it went into the mold, or whether it's been chiseled or something, and whether you can see means of fastening. Is it glued together or screwed together? Yes. These are how you tell whether something has been designed or not. And so even half a coconut has signs that it was made, because there are saw marks or whatever on it. But you're saying that you want to investigate lesser situations where it's not so immediately obvious that something is designed.
Yes, exactly. Because we haven't seen. We went there, to borrow a creationist canard. We don't know why life is here. It's a bit of a mystery. So that means that the tool that we have to investigate it doesn't have to just do really well at its own domain. It has to do so well that we kind of trust its extrapolations into uncharted territory.
Yeah, whether it works on Mars or somewhere else. Yeah.
Yeah, exactly.
So, should we do your slides?
Sure. Yeah, let's do it. Okay. Sounds fun. Yeah. So this is. So we kind of touched on a lot of this already, but I'm kind of working with the Steelman interpretation of the intelligent design argument, which is that they have a design methodology, which means that it can take an object as input, and then what it outputs is if it's designed or not.
Yep.
So intelligent design advocates' first step is that they claim that they have this. The second step is that they claim that they've put life into this methodology, and it's returned a result of designed.
Yeah.
And a third plank, which is a bit of a more subtle one, which I'm going to kind of try and lean on most in my slides here, is that this methodology that they've developed is robust enough that we should take it seriously.
Yeah.
That we looked at life and we said, and it said it was designed. And typically, the way that intelligent design advocates say that this isn't an argument from ignorance is that they've looked at a lot of things designed by humans, and they have got results with it that they're pleased with. They think it's really good. So we should trust it when it says that for life. This methodology has kind of changed over time. Kind of at first, the main thing was, look, life is complex. So if it's complex, it was designed. Life is complex, designed. Kind of moved away from that to irreducible complexity, which is a more specific type of complexity. If you take one part away from it, the whole thing fails. That's what you see in designed things. We see it in life. So life was designed. And the more common one these days is specified complexity, which is kind of going more into life is a code, DNA is a code, which we only see in designed objects. So I kind of want to take this at face value about how they should be analyzing it and where they are kind of messing up there. And I wonder if I have control of the slides here, or if that's.
No, I think I do. Maybe not. Oh, wait a minute. No, you've put it.
I do.
You've put up your other slides. That's the trouble.
No. Oh dear.
Leave those, and I'll just say next slide.
Next slide, please, John.
Well, before we do next slide, I want to say what we want to know is what's in that middle box, isn't it?
Yes, we want to know. What. So this box is methodology. So we want to find. So we want to do kind of two things, right? We want to. An intelligent design advocate wants to design the little box with intelligent design methodology.
Yeah.
But in order to do that in the first place, they need to say how to evaluate what good a job it does. And I think that they have gone about this in a completely amateur way. And because I'm such a lovely person who wants to teach everybody about how what a wonderful tool science is, I want to give them some tips on how they can go about that.
Yeah.
What the big things they're missing. And I would also like to say, I think oftentimes when having this discourse, I think people kind of get stuck in the weeds a little, talking about the actual chemicals, the actual evidence, the biology. And I think that's a lot of ways that's a shell game, because I think the load-bearing part is how, in the first place, do you take that evidence and use it in an argument to get something that's useful, something that you can trust the results of. Because that's the first step in science. You don't just go out and look at things. You need to say, what problem are we trying to solve? How will we know we have a good solution to that problem? How will we test it? And then we know what kind of evidence we'll look for. We'll know how to stress test our hypothesis.
And we need to have lots of controlled experiments so that we know that the effect is caused by the one causal factor that we're trying to investigate.
Exactly. Yes.
Okay. Shall I give you the next slide?
Oh, the next slide would be nice. I think we might skip over this because this is basically what I said out loud. But like I said, these are, I think, the three planks of a Steelman argument for intelligent design is that you kind of need all three of these to make these baked into the argument of intelligent design by detecting design and not an argument from ignorance. So we've got a methodology. Methodology says life is designed and that it's a robust, useful, testable methodology. We should trust its results when it says life is designed. So next slide, please. So I want to switch gears here about how we can kind of test a methodology kind of similar to this. So imagine that I'm trying to design a spam filter for your email. So an email comes into the box. It either puts it in your inbox or puts it in the spam folder. And this is a fun analogy, I think, because this is also a question of intelligent design itself. You're trying to tell if this was intelligently designed to trick you, or if it's an email you'd like to receive if you want to have it. But it's got to give you spam or not spam. So I'm programming. I'm making a spam detector, and I'm trying to sell it to you right now. I say, if my spam detector tells you that this is spam or not spam, you've got to trust its results. How would I show that to you? So,
well, we'd have to put lots of emails in and see them go into the two categories and check whether they've done it right or not.
Exactly.
And it doesn't happen at the moment, does it? Because sometimes something that we wanted to see goes into our spam, and we have to look there as well.
Yes. No detector is perfect. Obviously, no classifier is perfect. So yeah, this is something I like to beat a drum about a lot in my career as well. Is that when you're developing scientific methodologies, it's not just important to say what the output is, but kind of look at the error. How much error can you expect?
Yes.
So if I was programming this up, I would have, I'd have a database of different emails that I already knew were spam or not, and I would feed it into my algorithm to see how well it does. Yes.
And you'd have error bars on the output to decide.
Exactly. I would have a number saying this. You get like X% of emails that are spam go into the spam inbox, etc., etc. I'd have some metrics for it. So if you get a spam email, how certain are you that it was placed properly? Now there are some more complications to this with Bayes' theorem and stuff, because the proportion of spam to proper email it's not one-to-one, right? So there are some more mathematical steps, but this is the kind of scaffolding for understanding how we can go about scientifically testing this.
Yes. Okay.
Yeah. So go to the next slide, please. So here's my spam filter that I'm trying to sell you. So I say, well, I've got a database with 1,000 different spam emails, and I put it into my spam detector, and every single one of them goes into the spam folder. So I say to you, no matter how many spam emails that I know are spam go into the spam detector, every single one of them gets categorized as spam.
Correctly, yes.
Yes, correctly. It's 100% accurate. So is this a good spam filter? Did you actually get any information about if this is a good spam detector or not?
No, it's not, because it didn't categorize anything, did it?
No. So,
no choice.
Here's my next dramatic slide.
Ta-da!
No, this experiment gave you zero information about if this was a good spam detector or not.
Yeah.
Literally nothing. Well, it tells you maybe a little snifter that it could theoretically detect spam. I didn't put them all into the not spam filter, at least, so that's something. But it's next to useless. So if we go to the next slide, here's the program that I wrote. So the spam filter takes the email as an input, and it always returns spam. Without even reading it, it just puts everything into the spam folder, and that's how you get a 100% accurate spam filter that is also 100% useless. Nobody would buy this. I would be a terrible programmer for selling this to you. If I showed this presentation to the whatever conference people who program this stuff go to, they'd all laugh at me. It'd be very amateur. This is a very basic error. Nobody should make it. It's not serious.
Yeah.
So if we go to the next slide, this is how we can kind of do it properly. So when we look at classifiers, this kind of chart down here is called a confusion matrix. So we need to give it a mixture of spam emails and not spam emails. In order to know that this is a good detector, it has to tell you when something isn't spam. That's what actually gives you the information, being able to differentiate between spam and not spam. So we need to look at these 4 different cases. So you've got a spam email that's marked spam is a true positive. A non-spam email named spam is a false positive. A spam email named not spam is a false negative. And a non-spam email marked not spam is a true negative. So
why am I thinking of Monty Python with all this
spam? Yes. I could have picked something with a less silly thing I had to say over and over again. The other obvious thing here is drug testing, right? Where you can't just look at one of these quadrants and say, this gives us the information we need about if my methodology was good or not. I have to tell you what happens in all 4 cases. So if it's good, it's going to have a high proportion of true positives and true negatives, and a low proportion of false positives and false negatives. If it's a bad thing, we'll have the inverse. So so my very bad spam filter I showed you earlier was just was only giving true positives, but it would have given false positives as well. It never would have given false negatives or true negatives. So if I try to apply it, it would be rubbish, absolute rubbish.
Yes.
The other important thing to look at is that proportion itself, because you want to put a number on how accurate your spam detector is.
Yes.
You can do some tuning there, where you can typically tune these algorithms so you get more false positives but less false negatives, or vice versa, depending on what's important. You might make the deduction that someone values for spam, they want to have spam emails get into their inbox more than they want real emails to go into their spam where you don't see it. That's much worse. Might be about 100 times worse, right? So you might weigh these proportionately while tuning it. And so these are all the kind of considerations that also go into your intelligent design detector. How much do you value false positives versus false negatives? Can you tune it accordingly? And then all this, there are some formulas that go along with this that kind of tell you how to interpret your results.
So what we've got there is an outline of what the ID box in the middle has got to do. It's got to come up with that typical.
Kind of. I wouldn't say it's the box itself. It's how to say if the box did a good job or not.
Yes. But what I mean is the test of whether the box is working.
Yes.
But we still don't know what's in the box. We still don't know what the criteria are that enables it to decide which quadrant to send the emails to.
Yes, exactly. Yes. That's a whole thing as well, which we'll get into shortly. But before you even start designing your filter in the first place, you have to say, how am I going to test it? How am I going to know if it's good or not? What problem am I trying to solve right now? And that's the fact that you've got to separate spam from not spam. And that's what intelligent design needs to do, is how to separate design from non-design, which I don't. So what was I going to say there? So this is kind of maybe a kind of hammering the point home, but this is kind of familiar. Another kind of way of stating the scientific concept of falsifiability is that it's obviously very important to have something you can falsify. Otherwise, it's not really worth saying anything, is it?
No.
You need to know if what you're saying could be wrong. So if we go to the next slide, please. Because
where's the next slide? I'm not sure.
Next slide button.
Here we go. Yeah.
Yes.
Oh,
so we can go back, but we can just skim this one quickly, because you can kind of see where this is going. Is that intelligent design, to take the tiniest little baby step into proper investigation, taking this seriously, they need to be showing us their confusion matrix. We need to look at all 4 cases. And whenever you read any intelligent design methodology, any articles, it's always hyper-focused on the true positive case, exactly the same way my spam filter was. And that gives you no information at all. It has to be able to tell if something was not designed, and needs to tell how well it can do that, right?
Yes.
Which I can tell in the next slide, which I think is happening. I say, who cares? I mean, you put this nice little clip art I got from Google Drive, books designed, aeroplanes are designed, factories are designed. It always tells you designed, but who cares?
Yes.
And
so what we need is some criteria which are not maybe as simplistic as my examples, where we're looking for non-natural materials, signs of tooling, and fastening methods.
Yes, that would have the corollary that if you don't see those, you put something in the not designed box. That makes you start thinking, when humans design something that isn't when humans design something that don't have those traits, how do we detect that design, right? You can actually start investigating the problem, coming up with a useful methodology.
It has got more difficult recently because of what's it called? 3D printing. Because 3D printing doesn't necessarily have any tells to show where the tooling was working on the machine, on the production, and it needn't necessarily be of non-natural materials. You
Yes.
can use things like sand
Mm-hmm.
to make your 3D object, and it needn't necessarily show any signs of fastening. It
Yes.
can be done by heating or pressure or something like that. So that's a sort of recent development which makes it harder to
Mm.
distinguish between things that we do design, because we've got a better method of designing now
Yes,
that
exactly.
that's indistinguishable from something that's
It
not
does
designed.
complicate the problem. It's not a trivial problem to solve, which
Yeah.
is why I think doing the victory lap it's childish, it's
Yeah.
amateur. Um, you know, uh, Actual scientists who have to actually detect if something is designed or not don't act the same way, and this is why not hyper focusing on the true positive case. What you were talking about just there was the case of a what would that be? That'd be a false negative, right? So you might have something that's human designed that doesn't have tooling or
Yeah.
fasteners. That's a false negative case, and that's an important case. You need to look
Yes.
at that in order to make your design methodology better. You have to
Yeah.
do it, yeah, to
You're,
understand the limitations of your methodology. All
yeah.
this is something that scientists are constantly thinking about, and
Yes.
it's something that in general pseudoscientists do not think about at all. They only care about true positive cases. I think this isn't
Yes.
specific to intelligent design either.
No.
Um, right, like off the top of my head, maybe astrologers kind of do the same thing. They
Yes.
know a Scorpio who's a total dick or whatever. Uh,
Yes.
yeah, that's kind of my pitch to intelligent design guys who want to make their methodology a bit more scientific, a bit more grown up,
Us. Yeah.
robust. Yeah, how you can make scientists take you a bit more seriously, because if we go to my next slide, actually, is one I want to segue into, which is that when scientists engage with intelligent design, they are doing you a favor. It's kind of weirdos like us who are kind of like interested in kind of these quirky fringe ideas. Intelligent design, like John said, kind of has its peak when teaching creationism was outlawed in public schools in the
Yeah.
US.
Mm.
So we had this big peak, but that where you see it come down again is after the end of the Dover trial.
Yeah.
So this is the Google trend for intelligent design over time since 2004.
Yeah.
You see a few peaks when like Expelled, no intelligent design allowed movie
Yes.
came out, but it's just a slow downward slide into irrelevancy. Nobody
Yes.
cares about this. So you've got to put your big boy pants on, and you've got to make scientists care about your methodology.
Yes.
And for
Yes.
comparison, I put in the flat Earth. Uh, like
Yes. Yes.
scientists talking to flat Earth guys is a much better use of our time, really, because they have a much bigger cultural impact. Uh,
Yes. Yes.
yes. So that's my little spiel about intelligent design and what I think their major flaw is and how they could improve it if they wanted to. Um, I honestly don't believe that they want to, but maybe they'll surprise me.
Well, the trouble with whether they want to or not is it's going to be very difficult for them to come up with criteria that will enable
Yes,
them
it's a
to
hard
do
problem.
this. Yeah, to do this rigorous examination of the detection method that they need to apply and can't. So
Yes, yeah,
at the moment, they're happy to push that onto the back burner and say, "Look, here's the statistical unlikeliness that
yes,
anything can have been made this complex without a god being behind it."
yeah, which is not useful methodology. And
No.
I mean, and also these slides are just kind of cracking the surface on how to even start thinking about the problem properly,
Mm.
because like I kind of alluded to earlier, like you're kind of extrapolating from human design to
Yeah.
literally the omnipotent creator of the universe's design, which is a
Yeah.
little bit of a leap.
It
I know
is.
he created us in his image, but still, I think there might be a few hurdles there. It'd be kind of like if I spent all this time building this spam filter and then try to apply it to emails in Chinese, right?
Yes. Yes.
It's and even that is, I think, understating the jump that you've got to make. But before you even get
Yeah.
there, you kind of have to go through what I was talking about with properly analyzing the methodology and how to test
Yes.
it. Um, yeah, I think they're kind of buying into their shell game where you're spending a lot of time talking about
Mm.
the actual, like you said, statistical unlikelihood or chemistry, just isn't that useful if you don't know what to do with that evidence. Yeah.
No, no.
I
There
think it
was
does hark back that they think that science is just this a book of facts, right? They don't really care about the
yes,
methodology. There's a science book, and we open the science book like,
yes,
oh
yes,
yeah, that's true. All right,
yes,
gone.
yes.
Yeah.
Well, that is an educational downfall, I think, because in the early days of teaching science to children, most of it is this is true, this is true, this is true.
Yes.
You
Thought you
know,
might have thoughts on this. Yeah.
and none of it is this is how we know this is true. This
Yeah,
is, you know,
and that's the important part.
it's indeed the methodology. Yeah,
And kids are natural scientists as well. They're ridiculously
yes,
curious,
that's right.
and
Yes,
I think you really have to deliberately
uh,
get that out of them. You know, by
yes.
saying, nope, nope. You go sit down and you go memorize this.
Don't be curious. Turn this off. You know, you'll make a mess.
Yeah, yeah, exactly. Yeah,
Yeah. So their major problem is knowing what they're looking for,
yeah,
and
and
that's our problem too. We
yeah,
we can't really narrow down exactly what life is because I used to
it's true.
teach to 11-year-olds what the criteria or the characteristics of life were, and it's this list. It's movement. These are the processes that life does, you know, and this is
Mhm.
how we recognize it from a rock. You know,
Yes.
it shows a lot of these things. It shows movement. It respires. It feeds, you know, and it reproduces, and it's sensitive, and it has a relationship with water, a balance of some sort, and it grows and it excretes. And if you've got a good mixture of those things, that item is probably alive.
Yes.
However, that's a sort of ideal case, and it's looking at complex life. And
Yes.
there's a lot of examples in the diversity, the wonderful diversity on this planet of creatures that don't fulfill all of those characteristics.
Yep.
And some of them go in and out. I mean, they may fulfill the characteristics for a while, but then they go quiescent for years or more and can live in space. You know, I'm thinking of what are they called? The
Like viruses.
what?
Like viruses.
I wasn't thinking of viruses. I was
Okay.
thinking those little anthropoid creatures that it's a name that won't come to me, but they have been found to persist in a dormant state and then be resurrected subsequently. And somebody
Mhm.
will tell me what I'm thinking about in the comments underneath.
Sure. Oh,
Uh,
aren't those sea monkeys? That's what they're marketed as. They're like a bright, like little shrimp almost, and they kind of go
yeah,
dormant for a long period of time.
it wasn't those that I had in
Okay.
mind,
Okay.
but that sort of thing. Viruses are interesting because in order for them to be alive, they have to hijack a cell which has got all the
Yep.
equipment they lack. So
Yeah.
they're
The
just
universe
like,
is messy
yeah,
and complicated, and even with something that seems quite binary like life, you start digging down, and it's not so binary, is it?
no,
It's
listen. No.
hard to come
So
up with. Yep.
So I've talked about this with people like Lee Cronin that we were talking
Mhm.
about earlier, and it seems that the definition of life has been narrowed,
Mhm.
and we've said, you know, it doesn't have to move, it doesn't have to feed constantly, it doesn't have to respire even, you know, it
Mhm.
doesn't have to grow. But there's one thing that designates life and distinguishes it from non-life, and that's
Reproduction.
reproduction.
Yep.
It has to be able to make more of
Mhm.
whatever it is, replicate.
Yeah.
And
That should be the standard, but I mean, then even stuff like fire, you know, I mean, that self-replicates, doesn't it? But I mean,
well, and therefore it gets very, very muddy what the
yeah.
criteria are.
But then you've got to say, what am I trying to accomplish with this categorization? How does it give me useful information I can use to learn more? And you know, obviously, it can be useful here because to dig down on what distinguishes life from non-life, you have to really get into the weeds and see. You know,
Yeah.
you have to learn a whole bunch of stuff, right, to do it. But kind of whenever you make these categorizations are somewhat you know, they're, there is some concept called life that really exists, but there's also life as in this human conception of it, right?
Yes.
And there's a map and a territory, and it's kind of
Yeah.
hard to kind of tell the difference sometimes.
Mm.
Yeah.
Yeah. Well, there you go. Do you think we've put the world to rights?
I think so. I think after any intelligent design guy sees this, they're going to pack right up and they're going to go do something worthwhile with their lives instead.
Dream on, dream on. They're earning too much money because there's
Yeah.
a huge market for their outpourings.
Sure.
Nonsense.
But not so much anymore, but yeah.
Yeah, they can keep making books and selling them and making a fortune. They've set up whole organizations like the Discovery Institute, like Creation Research Society, whatever they're called, and they're earning good money. So they're not going to stop.
Although I am optimistic there. I think it's very likely that it's much less than they were like 15 years ago. Kind of living in the US, it was kind of like a big culture war talking point, this sort of stuff 15 years ago. But after it served its purpose, they discarded it and they moved on to other stuff, right? Like during the Trump years, they're not talking about the right to teach creationism in schools anymore. Nobody cares, right? They moved on to different culture war issues now that wedge has served its purpose.
Yes.
Nobody talks about it in the US anymore. Yeah.
Good. Well, that's the best news I've heard this week.
Yeah. So, I mean, I'm just kind of a guy with a weird hobby, really.
Well, it's guys with a weird hobby who actually make significant progress for the whole of humanity.
Yeah. I mean, not to pat myself on the back, but it does kind of come from the same place of being a scientist as the kind of being obsessive about finding out if something is true or not, right? And kind of put the same energy there. Is that like, how do I actually use science to investigate this? It's not just something I do for money. It's a passion. It's something that naturally comes to me. It's fun.
You use the word obsessive.
Yeah.
I think probably in order to achieve at anything, you have to have a mission. You have to be obsessive about it. I mean, if you want to learn to play a musical instrument, it's going to take you 10 years to be any good.
Yes.
So you've got to be pretty obsessive about wanting to do it.
That's true. Yeah.
To stick at it. And the same applies if you're an athlete, to achieve.
Yeah.
You're looking at a 10-year program to develop the skills necessary to be on the competitive top levels.
Yeah. There's joy and passion in people pursuing that, and not to take too many jabs at kind of the ID crowd, but a lot of times when you're talking to them about how to test their methodology, they treat you as if you're trying to trick them, and like that same passion I think it isn't there. I think it's very joyless. Maybe this would be kind of being more petty, a bit of a mean girl, but that's kind of the impression I get.
Well, the other thing that they do, which strikes me as very unscientific, is they come at this. Well, it's not an investigation, but they come at
a conclusion already.
Yes, they know what they want to try and prove. That's not science. We don't do science like that.
We make my job a lot easier.
we come at it with an open mind, and we investigate to see whether our ideas can be corroborated by observations in the natural realm or not. Yeah. And that's the big error that they make right from the beginning. Alistair, you've been fantastic. I thoroughly enjoyed talking to you.
Yeah,
We're coming to the end of our hour now.
Yes.
So I just want to say, and I do like to keep it to an hour because otherwise my future guests look at the long programs and think they don't want to commit themselves to a chat with me.
Time always expands.
They might get trapped.
Yes.
So I want to announce that next week we have another interesting guest. He's a winemaker now, but previously he was a minister, a clergyman.
Oh.
So he's got an interesting story to tell. He's abandoned the clergy and now he's on the side of Bacchus.
Bacchus?
The wine god.
Oh, yeah, Bacchus. Oh, yeah. Oh, wow. That's an interesting... Okay. I'll be watching that for sure.
Yeah. Tune in next week to see that show. And don't forget, you can take part if you want to put chats in the chat bar on the side. You can put text up there and I can screen it for you if we want to add it to this show. Alistair, thank you very much. Viewers,
thanks for having me.
Mostly future viewers, I think, today. Thank you very much. And bye-bye.
Bye-bye.